Start. Is it started? Okay, welcome to this lecture. This lecture is important for a midterm. So I'm glad that all of you arrived on time. And in this lecture, I'm going to first review the homework. And secondly, I'm going to review the lectures. So let's talk about homework 2 first. That was about using random number generator or something to generate a lot of 5,000 points. You remember that? Now let's talk about how you should do it. The first step is to inspect the data. So a lot of you just tell me, you told me, let me directly generate these points, generate that points. But I think before that, it's very important to inspect the data first. For example, there are 2 attributes. Then how are they distributed? You first have to inspect each attribute, right? Check the histogram and check if they are correlated. I think Guozhen is the only one that did this. So all of you forgot to inspect your data before you do something. So this first step, I want to emphasize this to you. You have to choose your tool based on your data, not directly apply a tool before you inspect your data. So how are they distributed? If you use the histogram, you will find that attribute 1 is almost uniformly distributed, and the other one is not. And in this case, you may think of firstly generating attribute 1. Then you base on attribute 1 to generate attribute 2. The second step is to find the curve. I mentioned in the class, I don't want you to use you only use the curve to represent the result. But you still have to find the trend. And after finding the curve, you have to answer what the R square is, which means how the curve fits your data. I don't want you to use the curve to represent the rule, or I don't want you to only use the curve as the result. But the curve you find is very important. So the second step will be to find the curve. Now I'm going to show you how to find the curve. The third step will be to generate those random points. So you have a curve, right? You find a curve. And there are 2 ways to generate these points. The first way is the conservative way, which was done by, I think, like Patrick. Like you were the one who suggested this. In this conservative way, for every point in the 5,000 points, you just randomly pick an existing point out of those 1,000 points I gave you. And that was conservative, because in this way, you are not going to generate any new points. No matter how many points you generate, they will always be the old points. And in this way, so for example, if you are going to generate 5,000 people out of 1,000 people, that probably means each person will be cloned 4 times. And that will make the world very boring, right? So in this conservative way, no matter how many points you are going to generate, they are always old points. But this is safe. It's safe because all the attributes are collected from the survey, and you can say that they are all correct. Like they won't be unrealistic. But another way is to do it in a progressive way. Some people just generated some new points by adding some noise to the existing points. But I think the correct way is to first keep all those original points. Only one of you did that. So you are not just wholly generating new points. You keep 1,000 original points. Then for the rest 4,000 points, you create them by modifying existing points. So the best progressive method is original plus modified. But when you choose the progressive method, you are taking your risk. Because how can you prove that the generated points are as good as the old points? I'm going to show this later. And the last step, which is the most essential step, is to validate result. These steps can be replaced, but in the end, you have to validate those results are good. So if you generate your points based on the fitted curve, you need this R square. You already got the R square when you fit the curve, when you create a fitted curve. So R square. And you can compare the standard deviation and mean of these two data sets. And this tool, these two tools were the tools that I expect to see, but nobody mentioned this. You can use density plot. I mean, in the result, you can use density plot or contour plot to show the density of points. And in this way, you can visually compare them. So these tools, I introduced that in GIS, right? So you have a 2D space, 2D surface, you have a lot of points. And there are too many points, so how can you tell if these two graphs are very similar? You can use density points. You can find a lot of point density algorithms. And this will be an effective way to show the users that these two distributions are very close to each other. So let me show you some good things from homework. The first one is, this picture is drawn by Lei, and he used the curve fitting tool in MATLAB to find the optimal curve. So you have to know there is a tool in MATLAB you can use, and you can choose different forms so you can find the curve. And here, maybe you won't see it. Here it says R squared is equal to 0.9668, which is 96.68% R squared. So this means a very good fit. So this is very good. I put it here. And this is from the homework of Jay. He had a new idea. So he had a fitted curve, the red curve, but he also created two curves called, which is one standard deviation away from the fitted curve. The reason for doing that is he wanted to exclude some outliers. But Jay also made a mistake here. When you use this curve, then you can compare each point to the curve. You can get their deviation. And in Jay's homework, he used a uniform distribution to select these points. But if you analyze it, you find if this is the fitted curve, then these arrows, residuals, will follow a normal distribution. So after getting this curve and these two range, you have to use a normal distribution to randomly generate points. But that's a very good idea. Do you understand that? You first generate this curve. Then you vertically compare each point to the curve. There will be a residual or arrow. And this arrow, if you draw a histogram, they will follow a normal distribution. So then you can use the normal distribution to generate the arrow of any new points. But you can first use the uniform distribution to generate x for attribute 1. Then you use curve to generate this point. Then you add a noise or an arrow using normal distribution. And this is another method which has been presented by Lili and Lei. This is called grid-based generation. And in this way, the basic idea of this generation is to divide this whole 2D space into grid cells. And for example, if I use a random number generator to pick any point here, then I can randomly create a point within this cell. And the reason behind this is it can ensure the density of the points won't change too much, right? So the smaller the cells are, the close that the density is to the original graph. But this is based on density, point density. So these are the things I want to point out. And India is the only one who gave out a mean and standard deviation table. And this is good. So these are original drivers. So he generated 2 data sets. For all data sets, he calculated the mean and standard deviation for both attributes. And he compared that to the new generated data set. And the conclusion is they are very similar to each other. Okay. Now let me proceed to homework 3, which is about how you can imagine how you can use ArcGIS extensions to aid traffic simulation. I use imagine, so you'll become very creative, and you mention all these things. I summarized this table. I deleted something that are not very relevant. First, I want to mention is this 3D analyst. Most of you mentioned that the 3D analyst can be used to visualize simulation result. Yes, 3D analyst can be used to visualize 3D things. But can you really use that in vSim? No, because vSim does not have any interface to this ArcGIS. So unless you have the ability to convert your simulation result into shapefiles or GIS format, you won't be able to use this 3D analyst. But it's good to imagine that. So in the future, maybe it's possible to do it. Now, you can take a look at this table. I want to mention this thing. This is good. It's good. So this is a linear referencing tool. And it can be used for dynamic segmenting. What does this mean? This means in your network, you always have the links with fixed length. But sometimes, maybe only part of the link, a segment of the link has something different. For example, a congestion happens within a part of the link. And you don't want to create a new network. Then you can use the dynamic segmenting to only display some attributes for part of the link. This is called dynamic segmenting. So part of the link can be displayed, can be marked as different colors maybe. And buffering is very useful. Most of you mentioned buffering. These are 3 things that are very good for example, identifying the coverage of flow detectors, and find the extent of activities. When a person is going to have to perform an activity, this activity should be within the range to its current location, and that can be found by buffering. And like this check transit route coverage, that would be very good. So if you have transit route,